Let's learn about the general formula that we can use to find an approximate and exact area under a curve. We're going to find the area under the curve y is equal to f of x. That curve is shown down here in our graph. And we're going to find the area from x is equal to a. That's down here on our left. And then we're going to go to x is equal to b, which is down here on the right. It is very standard to let n be the number of rectangles, and that's why we notate our right-hand endpoint as x sub n, and then delta x, shown up here on our graph, is just the width of each rectangle. Now we need to find a formula for the width, delta x, of each rectangle. It is equal to the width of the region under the curve, that's b minus a, all divided by the number of rectangles. Now we need to find a formula for each point between a and b. We'll start with our first point, and we're going to label it x sub 0, and it's equal to a. A is the left-hand endpoint. And then our next point, x1, is just going to be a plus delta x, and then x2 is going to be a plus 2 delta x. And then there may be a lot more rectangles, but then we're going to get to a general point, and we're going to call that point x sub I, and it is equal to a plus I delta x. The approximate area under the curve y is equal to f of x is equal to a, and it is the sum of all the rectangles. We're now going to write down a formula for the sum of all these rectangles. Our area is approximately r sub n. We call it r sub n because for this formula, the height of each rectangle is going to be approximated using a right-hand endpoint. Our formula then is f of x1 times delta x. Let's go back up here. That's just this height right here. That's f of x sub 1, and then our width is delta x. And then we have the same thing, f of x2 times delta x, all the way up through f of x sub n times delta x. Notice that all of these terms have a delta x in it, so we can combine them and we can pull out our delta x. This formula is really long, so what's done in practice is that this formula is written using what's called summation notation. I have a video on that if you need to review that. It's just a compact way of writing the sum of a bunch of terms. We can then say that the approximate area under our curve, A, is approximately r sub n, and it's the sum from I goes from 1 to n of f of x sub I times delta x. So it's just f of x1 plus f of x2 all the way up through f of xn, and all of those get multiplied by delta x. We can then find the exact area because we know all about limits, and we can say that our area is equal to the limit as n goes to infinity and I goes from 1 to n of f of x sub I times delta x. So basically, we are doing the same thing as in the approximate area, but now we have an infinite number of rectangles, and we're finding an exact answer when we let n go to infinity.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.